Welcome to another video. I'm Josh and this is JSurus. Today I'll be taking you on a tour of my workshop and some of my tools. What you're seeing now is part of the cleanup and organization I did in preparation for the tour. My shop has a tendency to get cluttered if I don't pay attention, so a big clean is sometimes necessary. This time I decided to record the cleanup so as I could try out time-lapse and have something more interesting than me sitting in front of a desk for an intro. So, while I clean at superhuman speed, I'll give you some background about how I got involved with metalworking. Afterwards, we'll go into the tour itself, and at the end of the video, I'll show you some of my past projects and a peek at my next one, so be sure to stick around. Now, as you can see, I have quite a bit of equipment in my shop, so it should come as no surprise that I'm pretty serious about machining. In truth, I've been involved in metalworking since my teens. I first took a serious interest when I realized that my high school had a full machine shop and an introductory metalworking class. I had such a positive experience there that I decided to study machining at a technical college after graduation. I took a one-year certificate course that covered all the important knowledge for a beginner, and this included things like metallurgy, metrology, hand tools, manual and CNC machining, and even a bit of welding. The most valuable experiences, though, came from the projects that we made at college, and most of those projects were various tools I actually still use today. So I'll show you some of the things I made in college and high school after the tour, but for now, let's cut over to the part that you all came here for. So now just a quick overview of everything in the shop. As you can see, I have 2 milling machines, a lathe, some accessories on that bench there, and over here we have a soldering station, some miscellaneous tools, and my grinders and sanders as well as my vise. Here we have my first milling machine, which is my Sherline mill. It is very small but also very accurate, and it has a very large selection of accessories for it, most of which are either on the table in front or in those plastic drawers. Now a little closer up you can see it really is quite diminutive, but it is really quite amazing. Obviously the table can move both in the X and Y directions, and the spindle can move in the Z direction. You can see that cute little vise there, and you can probably tell how smooth the mechanisms on this are, and there's very little backlash. It has very good compensation. Now as I pan up, you can see a bit closer a look at the spindle and the drive and controller. Now up there is where we have our Z-axis knob, and it's a little bit of an awkward placement, but given how small the machine is, it's not too bad. The motion is a little bit sticky on this one because I haven't lubricated it in a while. But as you can see, the controller is very simple, an on-off switch and a continuously variable speed. Here we've got some of the accessories. You have a Jacob's chuck. That there is actually a gear cutter, which I haven't yet ground into a shape yet. And on the far right, we have a fly cutter, which I actually use quite often, believe it or not. Now we have our larger mill, our big boy. This one is slightly less accurate, or rather, I'm not as good at being accurate with it, but it is very large compared to the Sherline, and that gives it great vibration dampening. It also has a lot more horsepower, as it were, so it can make much deeper cuts, and it has a much larger capacity on the table. Now, as you can see, there's quite a number of accessories with this machine. Over on the right, we have a hold-down kit, which is really quite useful, essential even. I'd say even more essential than a vise, as you can hold pretty much anything down with that. In the center here, we have a rotary table, which is actually intended for the Sherline mill, but you can make it fit on almost anything if you're willing. Those are just the hold downs for it. And there is something that I haven't used yet. It's an angle plate that's for the rotary table, but it's also for the Sherline. I also have a large number of end mills, both 4-flute and 2-flute. They're very good quality, and right here I've got my collets, which is the primary thing that I use to hold my end mills, as they are very accurate and repeatable. Now onto the milling machine itself. As you can see, we have the Z-axis wheel in a very convenient location compared to on the Shoreline. Some of these larger mills do have the Z-axis wheel on the top, but this one has it in a much better location. The X-axis wheel is also capable of freewheeling if necessary, which is useful because you can put an electronic drive on these, and that freewheeling ability will prevent the wheel from smacking you as it spins. Now the table, of course, has a locking mechanism, as does the spindle, and that is very useful for keeping things rigid. Now the vise that we have mounted on here is actually one that I built myself in college. It's cast iron, and I machined or turned every part of it. Next up, we have a close-up on the spindle and the motor head and all that. As you can see, we have a push-button interface on there and a nice digital display. I can increase or decrease the RPM in increments of 10. I also have a tapping function and a forward-reverse rotation. As you can see right there, my nice little digital height gauge does nothing because it uses a battery for some reason, and that battery is dead. However, my e-stop works just fine, and when you disengage the e-stop, it powers right back up. Now, given that this is technically a mill drill, that explains why we have the handles here for doing drilling. It is much more stable than a typical drill press, so it's a big advantage there, and you don't need to buy another machine to do your drilling unless you have more than one person working in your shop. Now what I'm doing right now is illustrating the tapping function. It actually has a little button on those handles that lets you reverse the direction of rotation as you are tapping. So when you get to the bottom, you reverse the rotation direction and then pull right back out. It's a very useful function, which I have not used at all yet. Now our next machine is my diminutive little lathe. This poor guy has seen better days and wasn't all that great to begin with, as it is a Chinese import lathe. It's very, very stiff. The cross slide doesn't work very well, and I really need to do quite a bit of refurbishment to it in order to get it to be usable. It also has a fairly limited capacity. It did the things that I wanted it to do, but I will definitely want to get a larger lathe, as with a chuck and the drill in place there, I have barely more than 6 inches of overall length on the workpiece. Of course, it has an e-stop like everything else except the Shoreline. It can go forward and reverse with that switch, and it's continuously variable on the speed. However, it does have change gears, which are actually for the threading function. Now here we have some accessories for the lathe. We have some wrenches, Allen keys. That green one there is for our carbide inserts. That is a chamfering tool for any holes that we make. And we have some quick change tool holders, which are actually fairly good quality. We also have a center and some jaws for our 3-jaw chuck, which is right there, and a chuck key, of course. And what's in the box there is our 4-jaw independent chuck. And in the back here is something I don't use very often, but when I do, it's quite useful. It's the faceplate. It currently has something super glued to it, which is a completely legitimate way to do things. And what we've got there is our original tool holder and a super glue chuck. Now over here I have my soldering station and a variety of accessories and tools that don't really qualify to go anywhere else. And over here I have the belt sander, a blade sharpening grinder, and I have my pedestal grinder as well. And we've got a bench vise, as you can see. That is extremely useful, especially when filing things. And we've also got a cheap little anvil, which is good for tapping in bearings or tapping out pins. And as I mentioned, the pedestal grinder with the dressing tool to keep it parallel. We've also got a variety of miscellaneous tools on the post there. Alright, as promised, I'm going to show you some of the projects that I made in high school and in college. On the far left here, starting out right away, we've got the first thing I ever really made out of metal. It's a C-clamp with a body made of sand-cast aluminum, and then powder-coated a nice shade of green. And then the first thing I ever made on a lathe was this screw here. I was very proud when that actually ended up working. All the other components here were turned on a lathe as well, and then just welded up together. It looks rather rough now, but I learned a lot making this thing, and so I'm glad I made it, and I have used it once in a while since I made it. The next item I'm a little bit more proud of, though not necessarily proud of the condition it's ended up in, but this was the first vise that I ever made. It's more of a drill press vise or a general purpose vise, as it doesn't have any tabs to mount it to a table like a mill vise would, but it's basically made out of some sturdy angle iron, welded up together as well as could be, and then machined flat along the ways with these jaws machined out of flat stock. And this lead screw here turned, that one is an Acme thread. The other one was a triangle thread, but I believe this is the first Acme thread I actually cut. And if any of you know what an Acme thread is, you'll know that there's quite a bit of math that goes into it, and it's not as straightforward as just making the right shape tool and cutting the thread. There's compound table adjustments or compound rest adjustments, and it really does teach you a lot about what a lathe is capable of and how to use it to its fullest. So I'm pretty proud of that, but I might be doing a restoration video of this vise at some point, and I might even be modifying it with some mounting tabs so that I can bolt it down to a mill table. So look out for that. Next, we'll go to the 3 items I was able to find that I made in college. At the top here, we've got a set here with a multitude of different punches. We've got a pin punch. One of the pin punches is missing, but we've also got some center punches. And this is a special kind of drift punch meant for knocking certain types of tools out of friction fits and spindles. This item is very useful, and I've used the tools in it quite a bit. And when it's cleaned up, it looks pretty nice too when everything's actually all in there. The thing right below it, as you might have guessed, is a smaller C-clamp. However, this one was the first real test of accuracy in college, and it was meant to demonstrate how accurately hand tools can make a thing to dimension. So it wouldn't seem like that because you think of a C-clamp as not necessarily being the most precision of tools, but we had very precise measurements and tight tolerances we had to make it to. All of these holes are precisely placed, and they're all threaded, as you may be able to see. And also the width here is very precise, and the chamfers, I am not the best at chamfers, but they were to be to a precise dimension, and everything was to be done on a bandsaw or a pedestal grinder or by hand. The only thing that wasn't, I believe, was this thread, and that was actually just a piece of threaded rod. Everything else was done by hand, and getting these surfaces flat and at the correct angle, that was all done with hand files. It took forever, but it taught us a lot about finishing and about how to make things like true and flat and how to understand what a flat surface actually is and how to achieve it. Now, our last item here, you saw in the previous part of the video, and this is the mill vise that I use every day. Well, every day that I machine, anyway. And this was made in college as well, and we got iron castings for it, and then we machined those castings to make the ways there and to square everything up. We turned this screw by hand. We made a brass nut in there. The handle is probably the part that I'm least proud of. I don't know what I was really going for there with that design, but it does work. It's, the jaws are pretty nice. They could use a bit of cleanup, but they are fairly nice. Most importantly, though, this thing is sturdy and it's fairly accurate, and it can be very well bolted down to the surface of the mill table. And that really taught us, that was the first thing I think that we made with a milling machine, and it really taught us how to mill large surfaces, how to set up a mill accurately, and the ways that you could screw up if you didn't set it up accurately. So I hope you've enjoyed this overview of these tools. I really enjoyed making them, and I hope to be making more tools like these in the future. And now, finally, as promised, a preview of my next project. I've actually got two different options for this, but they do the same thing. These are both hand vices. They just use a different mechanism. For those of you that don't know what a hand vise is, it is a vise attached to a handle. I just cut it off here in the drawing so as I didn't have to draw the whole thing, but the handle would typically extend to about the size of a typical screwdriver handle. And it essentially allows you to hold very small, awkward objects very securely by hand. Now, I grind a lot of my own tool bits out of high-speed steel, so that is probably what I will primarily use a hand vise for, especially if I'm making a custom drill bit or reamer out of rod stock. Especially for the really tiny holes, it is extremely difficult to hold on to such a thing securely if you're going to be hand grinding it. So these will be incredibly useful. Now, a little explanation I think is needed for the left-hand one. The right-hand vise is fairly obvious. You have a moving jaw here. You have your threaded rod going through and your knob on the other side. Your rod is fixed to the moving jaw, and it goes through a threaded hole in the fixed jaw, so when you turn this, you can tighten it or loosen it as you wish. I may make that into a hex bolt instead of a knurled nut to allow me to crank down on it a little bit harder. We shall see. But this one is a little bit more complicated and a little bit more elegant looking if you like the aesthetics of a tool. So you have your two moving jaws. There's no fixed jaw in this one, and they are connected by a linkage here. And there's a threaded rod that goes through that linkage and is pinned to it. Now that threaded rod goes into a threaded hole in the handle. And as you can see, there's a cone-shaped item here at the end of the handle, and that, when you screw the threaded portion in by rotating the handle while holding the jaws straight, it will cause these to move apart and these to move closer together, and thus it will grip whatever object you want. Some other people on YouTube have made hand vices like this before, and I really liked the look of them, so I'm going to design and build my own probably. I might end up making both of these designs eventually, but we shall see. There will be an update on that coming soon, however. Well, in conclusion, that's all I have for you today. If you like what you saw, hit like, and if you want more of it, hit subscribe, and let me know in the comments or in DMs what you think and what you want to see for future videos. Thank you.